Good afternoon, science students. Welcome once again to science, and I hope you're having a great day. I'd like for us to begin a brand new chapter today. As you know, this week we took our test over chapter 4. Now we are going to go back and pick up chapter 2 that we skipped over earlier this year. So at this time, I'd like for you to grab your science textbooks, and I'd like for you to open them up to chapter 2, which is on page 38 of your science book. Chapter 2 is entitled Energy and Energy Transformations. And I'd like for you to look over the photo that you see on page 38 and 39 of your book and try to think of all the different forms of energy that you see in this one photo. Of course, we see the sun in the background. Sun is the ultimate source of energy in our solar system, as we've studied in the last 2 chapters. Also, you can see the energy of the cars in the form of the headlights. We also know that the cars are moving down the highway, so there has to be some type of motor or engine driving the motion of the cars. And there's even energy in the plant life that we see in the trees and the grass and the surrounding area. So energy is all around us, and energy is something that we have to learn to conserve and learn to use correctly. So this chapter is about how energy is used, the forms of energy, and energy transformations. So if you look at the screen right now, you'll notice that the chapter is divided into 2 lessons. So this is a little bit shorter chapter. Lesson 1 on forms of energy, and lesson 2 on energy transformations. So we're going to go ahead and look at these different forms of energy today. First of all, what is energy and what are energy transformations? That is what we're going to attempt to answer in this chapter. Before we begin, decide if you agree or disagree with each of these statements. And as you view this presentation, see if you change your mind about any of these statements. So let's go. Let's look at the first statement. Do you agree or disagree with statement number 1? A fast-moving baseball has more kinetic energy than a slow-moving baseball. Do you agree with that, or do you disagree? Statement number 2. A large truck and a small car moving at the same speed have the same kinetic energy. Do you agree, or do you disagree? Statement number 3. A book sitting on a shelf has no energy. Do you agree with this, or do you disagree? Number 4, energy can change from one form to another. Do you agree or disagree? Number 5, energy is destroyed when you apply the brakes on a moving bicycle or a moving car. Do you agree with that, or do you disagree? And number 6, the sun releases radiant energy. Do you agree or disagree? Now let's turn in our book to page number 40. And I'd like for you to look at this very unique photograph of a cat. This photograph was taken with a very special type of camera called an infrared camera. In the drone industry, we call this a FLIR camera, F-L-I-R, an infrared camera or IR camera. And this camera detects the temperature made by this cat. What part of the cat do you think is the warmest? That's right, it's the cat's eyes. What part of the cat do you think is the coldest? Yep. It's the cat's nose. Sometimes you can touch the cat nose and you can feel that the cat's nose is pretty cool. So this tells us the temperature of the cat in different areas of its body. So the cat is giving off energy. So we're going to look at the question of what is energy in this first lesson. We're going to look at the question of what are potential and kinetic energy, and how is energy related to work, and what are the different forms of energy. Now, I'd like for us to look at your worksheet that I've attached to this lesson. It is notes page 47 for chapter 2 on note-taking. At this moment, I'd like for you to go ahead and put your first and last name at the top of the page. Go ahead and put today's date down and put your class abbreviation at the top of the page. And then at the bottom of the page, we have our vocabulary for lesson 1 and 2. So I'd like to spend a minute and go over the vocabulary for lesson 1. Here is our first word.
Energy, the ability to cause change.
So that is our first word, energy. Our second word is
Kinetic energy, energy due to motion.
And our next word is
Potential energy, stored energy due to the interactions between objects or particles.
Our next vocabulary word is
Work, the amount of energy used as a force moves an object over a distance.
Our next word is
Mechanical energy, sum of the potential energy and the kinetic energy in a system.
And the next vocabulary word is
Sound energy, energy carried by sound waves.
And the next word is
Thermal energy, the sum of the kinetic energy and the potential energy of the particles that make up an object.
And the next vocabulary word is
Electric energy, energy carried by an electric current.
And the next one is
Radiant energy, energy carried by an electromagnetic wave.
And the last word is
Nuclear energy, energy stored in and released from the nucleus of an atom.
So as you can see, we have many vocabulary words in this first lesson. A lot to learn about the forms of energy. Go ahead and put this page away and now look at notes page 48, which I'll have attached to this lesson. And let's get started with our first lesson on forms of energy. Again, have your book open to page 41 and your notes open to this worksheet 48. If you're in my homeroom, you can go ahead and use your frog book instead of downloading these worksheets for your notes. So let's talk about what is energy. Energy is the ability to cause change. So you write this in your notes. I found this on page 41 of my science book. Energy is the ability, put in the missing words, to cause change. Energy can cause changes in the motion of objects. We know that to shoot off a rocket, it's sitting still. It has to move. We have to have a rocket fuel and rocket engines to cause that motion to happen. To start a car, move a car down a highway, we have to have energy from the engine and the fuel that fuels that engine. So energy can cause the change of motion of objects. If you want to throw a baseball, you have to apply energy to the ball through the muscles of your arms, also the muscles of your legs and your back, to be able to apply energy to the motion of the ball. So energy is the ability to cause change, and these changes can be the changes in the motion of objects. Now, there was a very smart scientist that talked about motion of objects. His name was Isaac Newton. And Sir Isaac Newton came up with the 3 laws of motion, which we may look at a little bit later on in this chapter. And he talked about how objects move. So energy is an old word. It comes from the Greek word energeia, which means activity. So hopefully you have that note. Energy is the ability to cause change. That is what energy is. Now, let's look at some examples of energy in your next series of notes. There is 4 boxes here for examples of energy. And the first box, I'd like for you to write the word light. Light is a form of energy. We know that light comes from the sun. It's a form of energy. Light comes from a light bulb. A candle gives off light as a form of energy. Another example of energy, your second box, is sound. Sound can be very powerful energy, like the launch of a rocket can be so loud that it can knock you over. Thunder from when lightning strikes, very, very loud form of energy. Putting your earbuds in your ear and you hear the energy of sound vibrating from the membrane of the earbuds. So sound is a very unique form of energy. Sound energy does require a medium to flow through, unlike light. Light from the sun can go through the vacuum of space and still reach Earth, but sound requires a medium, which would be a state of matter, a solid, a liquid, or a gas for sound to go through. So there's no sound where there is a vacuum, where there is no solid, liquid, or gas. Out in space, if you clapped your hands on a spacewalk as an astronaut, you would not hear that sound. There is no vibration of atoms to create that sound. You hear the sound of my voice today from the speakers on your iPad or through your earbuds as you're watching and listening to this lesson. And it's going through the air and then vibrating your eardrums. So sound requires solid, liquid, or gas for it to travel through. Believe it or not, you can hear sounds when you're in a swimming pool and you're swimming around at the bottom of the pool. You can actually hear people talking that are standing next to the pool. We know dolphins and whales use sound to communicate through water. And sound can come through a wall or other solid objects. So sound can travel through a solid, a liquid, or a gas. Your third example of energy is a change in position. Write down change in position. When one object moves from one place to another, there is energy that is applied. And your fourth example is a change in motion. So if a car is moving down the highway and it needs to turn left onto another road, there is a change in the energy because there's a change in the motion of the car. So let's talk a little bit more about motion. And let's go to the next section. And when I say the word
kinetic energy, energy due to motion.
So kinetic energy is the energy due to motion. That's what I want you to think about as soon as you hear the word kinetic energy. So let's go back to your notes, page 48, and write down next to kinetic energy, the energy of motion. I found this on page 42 of your science book. So go ahead and turn to page 42, and you can see at the top of the page a photo of a box truck and a couple of cars going down the road. We're going to talk about that in just a few moments of the different types of motion there. So let's fill in our notes. Complete the sentence frame to explain kinetic energy. Kinetic energy depends on two things. And those two things are speed and mass. Speed and mass. So let's look at our notes on this slide. Kinetic energy is the energy due to motion, and all moving objects have kinetic energy. There's another key fact. The faster an object moves, the more kinetic energy it has. And then the last key fact, if two objects move at the same speed, the object with the more mass has the more kinetic energy. So on your chart for your sentence frame, on the left, you should write down kinetic energy depends on, and then it branches out two ways. On the top line, I want you to write the word speed. And on the bottom line, I want you to write the word mass. And then on the last line, of an object. So kinetic energy depends on speed and mass of an object. I think all you need to write on that is speed and mass. So let's talk about how this looks in this diagram. The kinetic energy of an object depends on its speed and mass, as we just said. And the vertical bars that you see next to each of these moving vehicles shows you the kinetic energy. So let's look first at the blue car. The blue car has a speed equal to 25 meters per second as it's going down the road. And the blue car has a mass, it weighs 1,500 kilograms. Look at the car behind it, the green car. Now the green car is moving down the road at 15 meters per second, so its speed is slower than the blue car. However, these two cars are identical other than their paint job is different. The mass of the green car is 1,500 kilograms. So notice the kinetic energy bar between the two cars. Which object has the most kinetic energy, the blue car or the green car? That's right, the blue car does. And there's a little expression you're going to learn when you are learning to drive here in a few years, which kind of scares me to think about all you guys driving here in about 4 years. And that expression is speed kills. So when you're in a car, and if you're speeding and you're going faster than the speed limit and you lose control, you cannot fight the science. Kinetic energy is building up as you increase that car. We live in a racing state. The racing capital of the world is Indianapolis, Indiana. And we all know, if we've watched the Indianapolis 500 for many years, that there have been car racers, car drivers that have lost their life racing at the Indianapolis Motor Speedway. When you're going 150, 170, 190, 200, 210, 230 miles an hour, and you hit a wall, there's a lot of energy in your body and in that car that has to dissipate. And if it doesn't do this correctly, it will kill the driver. So speed kills. And it's because of this chart and this screen that you're looking at. Let's look at the box truck that you see in the background. Notice the box truck's speed is the same as the green car. It's at 15 meters per second. However, this truck weighs a lot more, 8,000 kilograms. So this box truck has much more kinetic energy. In other words, if the driver of the box truck and the driver of the green car would hit their brakes at the exact same second, the green car would stop faster. Why? Because of the fact that there's more energy in that truck and the brakes cannot slow down that energy as fast. So truck drivers that are going quickly take longer to come to a stop than the equivalent of a car. That's why when, semi-trucks have accidents, it's usually pretty bad because of the fact there's so much kinetic energy built up in the mass of the object. So just remember what the sentence at the top of the screen says. The kinetic energy of an object depends on two things: speed and its mass. These are key scientific facts that you cannot change when we're dealing with science. So what is kinetic energy? It's the energy of motion. And the last note that we're going to take here at the bottom of notes, page 48, is
potential energy. Stored energy due to the interactions between objects or particles.
All right, so write this down. I found this on page 42 of our book. Now, I'd like for you to think about the word potential for a moment. If I would say to you, hey, you have a lot of potential, that means I think you are very smart and that you can do a lot of things in your life. In science, when we say potential energy, this is very similar. It's something that's stored up inside that object. And it's stored up due to the interaction between the objects and its particles around it. So for your notes, write this. I found this on page 42. Relay information about potential energy. You're going to write down potential energy is stored energy. That's the right-hand box, stored energy. And then we're going to talk about the three forms of potential energy. The first form of potential energy I'd like for you to write in the lower left-hand box is called the gravitational potential energy stored between objects and Earth, depends on its height and its weight. So if I take a pen that I have in my hand and I drop it, I know you're not going to be able to see this very clearly because of the fact that the camera is not following it. So I'm going to kind of back up a little bit. And you see this object drop. You know that in my hand right now, it has the ability to drop, but it has not dropped yet. So I say that it has potential energy. Then I go 1, 2, 3 and drop it. The energy goes from potential to kinetic energy, or the energy of motion. Now, if I raise the pen much higher and drop it, the weight of the pencil has not changed, but the pencil or the pen's height has changed. I drop it 1, 2, 3, and I drop it. It hits the floor much harder with a lot more energy than it did the first time. So the gravitational potential depends on two things. I'd like for you to maybe write that right below the box. Write down the word weight and the word height. The weight and height of the object. In other words, if I have you jump off your chair in a classroom onto the floor of the classroom, it's not going to hurt when you land. But if I take you up on top of the school and I say, hey, jump off the top of the school, when you hit the grass outside, it's going to hurt, potentially break your bones because of the height of that. So the acceleration of the kinetic energy in your body happens the longer you fall. You build up speed, and that speed, again, kills. Kinetic energy and speed can be deadly. So when we increase the height of an object, it will increase its speed during a free fall. And then, of course, if you jump out of an airplane and fall, it's going to be a very fast speed that you're falling. The second box of type of energy I'd like for you to write down is called elastic potential. Elastic potential. Elastic potential energy is energy stored in objects that are compressed or stretched, like a rubber band, for example. So rubber bands can store up that energy and then you let go of the rubber band and it can snap and hit your finger and kind of hurt a little bit. But as long as you have it stretched out, that is elastic potential. Some of you are on the archery team or have been on the archery team. We know that a bow has the elastic potential energy that's released, and then kinetic energy of the arrow is shot across to a target, okay? So that's an example of elastic potential. Now, below the word elastic potential, I'd like for you to write the word compressed or stretched. Maybe they're at the very bottom of the page. It's something that's compressed or stretched. So I'm talking about a rubber band or a bow, that's stretched. What about a spring? A spring is compressed. So it's under a lot of energy. When you let go of the spring, it'll release that energy outward. And we've kind of all played with some springs that we can see that happening. And then the very last type of energy I want to talk about, write this down in the last box, is called chemical potential energy. Chemical potential energy. And then put the definition right below the box or in the box if you have room, or below the box. This is energy stored in the chemical bonds between atoms. And on the screen, this is a very, very important molecule for the human body. This is called the glucose molecule. Some of you may know what the science word glucose means. Translate that to English, it means sugar. So this is sugar that is in your bloodstream. And glucose then is released, and these chemical bonds are broken in your bloodstream as you burn sugar when you're moving. So glucose is very necessary, and that energy is necessary so that you can run across the playground, you can run up down the basketball floor. It's the energy of chemistry between these atoms. And remember, these atoms look like circles in this diagram. Hopefully you can try to figure out which atom is which. The small ones, what would they be on the periodic table? Oh, I heard that answer. Someone said in the background, hydrogen. That is correct. And the larger gray ones are carbon. The question is, what is the red ones? Oh, someone guessed it. That is oxygen. So this is a carbon, oxygen, hydrogen mixture, or what we would call glucose or sugar. That concludes our lesson for today. There will not be a homework. I'd like for you to save these files. We'll print these out later when we get back to school. Or if you're in my homeroom, you can just go ahead and close your frog book, and we'll pick up later with the next page. Hopefully you guys are having a good week. We'll get back to this lesson on energy. We're not quite done with it. We have several more pages to go to work our way through this lesson. So there's no homework for today other than just taking notes and getting started with this brand new chapter, chapter 4, on energy and energy transformations. I will see you guys later. I hope you have a good day. Take care of yourself and stay healthy and safe. And we'll talk to you very soon. See ya.